Good afternoon, everyone. We're going to start the second part of today's presentation. We're going to start with two electrical engineering teams. We had a little mistake on the schedule. We're going to have the smart hydroponics team first, and then we're going to have the automatic attendance team. Hydroponics, are you guys ready?
Yes, sir.
Please start.
Thank you. Good afternoon, everybody. My name is Agustin Camposano. My group members are Mike Salin, Nelson Noche, Alex Solarte, and Chinon Sonanque. Our group worked on the smart aquaponics hydroponics system. Aquaponics consists of two cultivating systems integrated into one. The first integrated system is aquaculture, which is the cultivation of fish. Second integrated system is hydroponics, which is the cropping of soilless plants. Hydroponics and aquaculture combined developed our aquaponics system. The aquaponics process consists of nutrient-rich water that is transported from the fish tank to a grow bed. The plants receive their nutrients from the fish waste, and in turn the plants filter the water that is returned back to the fish tank. Our project's goals were to automate and monitor the entire aquaponics process. We also wanted to make it user-friendly so anybody could grow organics, considering any space limitations. I'll pass it over to Majid.
Thank you. Hello everyone. As you guys may know, most of the brilliant ideas came up as coincidences or more like providence. Such an example as the law of gravity with Sir Isaac Newton and the apple. Similarly for aquaponics. So during the period of the Aztec period, aquaponics, during the Aztec period, aquaponics was cultivated in Aztec agricultural lands, and the lands were known as chinampas. It was considered the first form of aquaponics in the system, where the plants were stationed in where the plants were raised in stationary islands or sometimes movable islands, and in lake shallow waters, and where the wasted material dredged from the Chinampas canals and surrounding cities, who manually irrigated the plants. For example, in South China, Thailand, and Indonesia, who cultivated and farmed rice, who farmed rice as well as in combination with the fish, is cited as early examples of aquaponics. Since the world got the idea of aquaponics, some people wanted to perfect the system by making it more automated and more functional. So they started taking the system as into large farms, or they can even do it in their home backyard or in the garage. As for the automation part, I'll pass it to my group member Alex. He will explain the hardware.
Good afternoon, everyone. My name is Alex Solarte. So I'm going to be talking about the hardware of the project, and also the design of the project. So as you guys can see here, this is basically a common aquaponics design. So we have a fish tank right here, and then that's the grow bed. That's where the plants are going to be growing. So basically what we're doing is using a pump to transfer all that water into the grow bed. However, this is basically a normal and common aquaponic system, so we try to make it smarter. So what we did was, okay, let me show you this first. This is our first, our initial prototype, and this is our final project. So what we did was make it a little bit bigger. So we use a 20-gallon tank for the fish tank, and we use a 24 by 12 grow bed. So that's where the plants are going to grow. So this is the complete system. Afterwards, we're going to show you guys a video of everything working. So this is the part of the design. We're also using a belt siphon, which is gonna be draining all the water from the grow bed to the fish tank. That way we can recirculate all the water. So as you might know, like we try to make it smart. So in order to make the system smart, we needed to use a lot of different sensors to track many different variables. So we use a pH sensor to make sure that the water quality was good for the fish in the tank. We use a light intensity to make sure that the plants were getting enough light, since we're basically replicating sunlight. We use a water leak in order to know when the system, if we had any leakage in the system. So that would let us know. We use a moisture sensor, a turbidity sensor. The turbidity is just basically there just to tell us how cloudy the water is and if we needed to change that water. And of course, we have a temperature sensor because we need to monitor the water in order to see if it's safe for the fish and obviously for the plants as well. So those are the sensors. So other hardware that we have a fish feeder that we have to make ourselves. So we 3D printed that, and then we use a servo motor that we are connecting it to the microcontroller, which is the brain. The microcontroller that we're using is an Arduino Uno. So what we're doing with that is basically connecting everything to that, and the software part, we're gonna explain that later. So, but this right here, these are basically the water filter that we're using. This is a heat pad for the water, so we can keep it at a constant temperature, and that's the pump we're using, and that's the LED that's recreating the sun, the light that the plants need. So after that, like those are not integrated into the microcontroller because those are some things that need to be there constant in order to keep the fish safe. So this is basically a 2D model of the actual circuit, and here you can see the actual schematic. So I tried to put this in here so you guys could see some of the connections and stuff, because this is like very, it doesn't show like, I wasn't able to expand it too well, so I used that. So like I said, so we try to automate the whole system, and in order to do that, like we used all these different sensors, and we did all the circuitry and everything that was needed. And we also developed a user interface so everyone can basically manage and control the system. So to explain a little bit more about all that, I'm going to pass it down to my friend Melson, who's going to explain the software part.
Good afternoon, my name is Nelson Ochi. So what the control system is pretty much, so we know the Arduino is the brain, is the microcontroller, but with that, for it to work, it needs some messages to be sent to, like directions, what to do, like the codes that need to be sent to for the sensors to be working at a certain time for another amount of time. So the operating language that that was used from the project is a C or C++ because it's known for its flexibility and versatility. And there's also something that we've worked with this whole past 2 years that we've been here. So it's pretty much common for us. So the software design is to use a lightweight measurement. So when we put everything together, we don't have we've seen other aquaponics projects that are more heavy in the software where you can't put the software, on the display. You have to drill it to something. So ours is just to make it lighter and load in a box that you can see everything in, everything connected. And then, like I said earlier, this control system, what it does is allows you to run modules together as once a minute or passing for different iterations. So when we run the code, you can see everything working, and because the code gets affected by the graphical user interface, or GUI. So what the GUI shows is just the GUI will show everything running to make sure the code is working. So it's like it works together. So if something is wrong with the code, we can actually fix it on the GUI on the interface. Or if something is wrong with the interface, we can fix it on the code. And here's a block diagram of how everything is hooked up together, of how we have hooked up everything together. So we have the sensor as its own network. You put in the control where that's the motors and everything comes in a microcontroller. microcontroller. That's the Arduino part, and everything is in with the code. What the code does is does data acquisition and send it to the graphical user interface in order we get a better result from it. And then the data is acquired and updated on the graphical user interface that you will see. And this is like this is a picture of our interface when we run the code. So with this, so it tells you pretty much everything that you need, from the water temperature, when the heater's on or the it's off, when the cooler's on or off. Because like my teammate said earlier, the plants need the fish need as Indians to be at a certain temperature. It can't just be all, cold all the time or hot all the time. So what it does is it turns on. When it hits reach a certain temperature, it shuts off and the cooler turns on. And then also this is with a pump. When the pump is off, and we have a timer for the pump. We literally we're running the pump 15 minutes on and 75 minutes off. This is just for an example for you guys to show how your interface looks like. And for the next part, I'll send it to my group member, Chinosu, okay?
How you doing? I'm gonna go over some of the advantages of our system. Some of the advantages of our system is faster growth. This works, aquaponics works by automatically getting the complete nutrients from the aquaponics works by getting the complete nutrients to the plants to the roots without drowning the plants, okay? Another advantage of our system is we have no weeds or pesticides or pests. In our system, pesticides are not used, so there's no risk of toxic chemicals because there's no soil with our system. It's a soilless system. Another advantage is great plant quality. Since the plants get all the nutrients they need all the time, like we mentioned before, it's automatic, so they get all the nutrients they need all the time. It rewards you by the plants tasting good and the plants being very strong. Yes. Another advantage of our system is it can grow in any condition. Indoors, outdoors. It doesn't necessarily need sunlight. We have implemented into our system LED UV lights, which just promotes the growth of the plants, no matter where it is. It could be outside, it could be inside, it could be underwater. Either way, it'll still grow very nicely. And we're going to show you the video now so you can see what it actually looks like.
So the next part will be on a future modification on the project. So future modification, like you've seen, we use a certain amount of sensors. If the things about it is, you can actually make the project better. You can use more sensors to enhance it, to make it, add more variables to it. So it's a growing project that it just keep growing every day because people are always trying to do different things with the project. It's not like we use a certain amount of sensors, but you can always do better with it. It's always more. And then the next slide is our conclusion. This will be our system working, and we'll show you the plot. Is there an audio? We don't know if it has audio, but like if it has audio, you can see everything working in there. The data changes every time on the GUI. Whenever the GUI wants it to shut off the light, it will shut off. After the plant's got a limited amount of light that it needs, and if the plant's got an amount of water that it needs, the pump will shut off. And in there in the pond, you might not see, but we have some tilapias in there that are actually helped us grow the plants for a good amount of time. Any questions or comments? So with that, for the nitrogen part, we can actually use an EC sensor. The EC sensor is an electroconductivity sensor. What it does is it monitors all the nitrogen, the the plants are getting, and then it also monitors the ammonia
Yeah,
of the
it's
fish.
coming from the
That's
fish.
going again. The problem we didn't input that is because it was pricey and it was almost out of range of our.
We don't have
Budget.
time to have the dosing pumps too.
It was out of the budget because the budget we were given was 800. And if we were to add the EC sensor, it would have been a little bit up above the budget that was given. That was told for us to get. Yes, sir.
I might have missed it, but where were your requirements and how did you compare your final system to those requirements to make sure they were met?
If we go back on, I think it's.
So that's the initial program.
Yeah. So this one is a project. It's the same project, but we did this in November with and last semester. Yeah, November last semester. We were just doing trying to make it small and compacted first, but we found out in order to do that, there was not enough space. In order to make the project bigger, we had to give some the requirements that we needed were.
Yeah, and to add a little bit of to that, like the first prototype that we did, it was like small, so there was no way to like place all the sensors in the system either, because it will look like it was too much to put in the tank as long with the fish. So we try to make it bigger, and that way we have more space and we can accommodate everything better.
When you say bigger, what size though? What
We-
was the
we were using
requirement spec?
So like there was no
At first-
requirement specs actually have a specs because we just made it bigger because we were trying to automate it. The smaller one couldn't be automated easier.
Yeah, and
So
to
we
refer-
had to shove everything in the tank. It just didn't look presentable at all. It was just
Yeah, and to add a little bit more about that, like our system, we basically built a control for an aquaponic system. So basically, it doesn't matter what the modifications of the tanks or whatever it is we're using, like we can always like update that because the system will always work with the same control. So those modifications, it's up to the user.
It's
what they
adaptable.
want. Yeah, it's adaptable. So it depends on what you want.
yes, sir. Yes, sir.
Yes.
So yeah, I have a couple questions. First of all, wonderful presentation. Congratulations.
Thank you, sir.
You're one step away from the graduation, right?
Yeah.
Yes, sir.
So I have two questions here. To be an engineer, when you go to work, I'm sure maybe some of you already got a job offer, I hope so.
Mhm.
So there are two important questions here. Number one is what is the marketing study, marketing requirement versus the design specification? I think the other professor, I think he's asking for the question, what I want to combine into one. It's
Mhm.
very important to be an engineer.
Yeah.
You need to design something better, faster, easier,
Yes.
not cheaper, less cost. The cheaper
Yes.
is not bad.
Yeah.
Cheaper is won't work, right?
Yes.
So I think in your presentation, I'm sure you probably did it, but you didn't include it in a PowerPoint slide.
Mhm.
You need to be able to compare the data you have today. Like for instance, when I see your future modification to get a bigger microprocessor, to me, that's not the real world engineers comment. Because you want to see what is the bigger microprocessor do what, compare with what, how to improve it, right?
Yes.
So I think your project is an improvement of the existing design.
Yes.
I would also like to see, have some data to support you why you're doing this to do something better, automatic, because as you guys said, China, Southeast Asia, all the countries, they are doing this already.
Yes.
So I would suggest you in the future, maybe you already did, I'm sorry, I'm not trying to criticize.
No, it's
No,
okay.
no,
It's okay.
So you need to have a data point, right,
Mhm.
from the existing model, and then you identify the marketing requirement, and you say, okay, your prototype is going to include this. Based on the test data, you prove it.
Yes,
Okay.
we weren't like very clear at the beginning, but like right now, currently, like if you try to buy an aquaponics system, basically you can go to any online store, any like place, and you can't find that. You will find a hydroponic system, which is the grow of plants without a soilless plant, basically. So what we did here was trying to implement both systems, the aquaponics and the hydroponics. So that means that with the aquaponics, we can even like use the fish after they grow like a certain amount of size. We can just take them out and change the fish. And once we put, yes,
There's
sir.
a company in Nevada that sells these.
So
Yeah,
yes,
well, most people we did some research on that. Like most of these companies, they sell for like bigger farms and stuff like that. They don't do like something like compact for you to have at home.
So-
Are you sure?
So here's to reiterate what he said was the point was to make it something compact that you can have on your kitchen counter, and just whenever you needed some, you can just put some microgreens in it and plant. So whenever you can have, like, let's say you want to have a salad like a spinach or lettuce, it's something you can just grab from your counter and then, you know, make a good salad and eat. So the idea is we made it bigger to improve it, but the whole idea was to make it smaller that you can put it. Like if you don't have, like someone can just put it anywhere and then literally just get like, oh, here's, you know, it's time to remove the plants and put plant the other plants.
And like we said, it's basically, the main thing here is basically the control. So if you need to change the size because you don't, I mean the bigger project can't fit in your house, you can always change the tank or the grow bed, it doesn't matter. So you will always.
I think I just want to emphasize, you know, maybe one step away from to get a real job, to work in the industry, and be careful. You need to have a design specification versus the marketing requirement. You better do a good marketing study.
So
and you also need to have a cost comparison between the existing one already in the market versus this prototype, which we're going to produce maybe 2,000 or whatever the number is, right?
So about
Wonderful. I'm sure you guys have done that detail, but again, I'm sorry to go the time.
no, exactly.
Yes.
So feel free to talk to me because I'm at HCC.
Okay.
So I'm upstairs somewhere. So feel free. Thank you. Wonderful job.
Thank you, sir.
Any more questions?
But all right, on the marketing side that you've said, the ones that we've seen are really big. Then those are like the ones that fit in the backyard, and they normally go from $2,000 to $3,000. But this one we were able to build. The one that we built, where we use about a maximum of $500, and we're trying to make it as, you know, as cheaper as we can, because most people, they use like really huge PVC pipes and everything for the drains and really big reservoir for that. That's the problem. We were trying to make it cheap, a little bit cheaper.
Thank you. One last comment. I will say that, for example, in regards to the specifications, why you went from a small to big? I mean, because maybe you were testing the system with a goldfish, and now you wanted to go into a tilapia size.
Yeah, tilapia.
You know, but where is the size coming from?
So
Because we needed bigger fish, like in order to because we wanted to put more plants into our system.
Yeah.
So in order to do that, we needed to accommodate bigger fish. So that's why we went with tilapias and we increased the size of the.
To create more money that
Also-
support the plants.
also for about that is we have to some thing is like for one fish needs about 10 gallons of water to be able to.
That's the kind of thing that is missing in the specification.
Yeah.
Now we wanted to have one fish, we needed 10 gallons.
Yeah.
That's why
We
if
have
we have 20
20
gallons,
gallons,
we can have two fish.
Yeah.
That kind of explanation was
Most of
lacking.
that information is in the actual report of the
The final
project.
design.
So we didn't feel like it was necessary. So that's our bad
Yeah.
in our part that we didn't put it on the actual presentation, on that slides. So that's our mistake.
Thank you, Tim.